Around 500 years before the birth of Christ, a Greek mathematician made a claim so strange that it has never quite gone away. He said the planets sing. Not metaphorically, actually sing. Each one sounding its own note as it moves, all of them together making a harmony so vast that we are deaf to it. He claimed to have heard it. And 2,500 years later, physicists would discover that the universe really does hum, and that the Greeks may have been listening all along. His name was Pythagoras, mathematician, mystic, the man who turned the world into a number. The story goes that he was passing a blacksmith's shop when he heard hammers ringing on anvils. Some pairs sounded sweet together, others clashed. He weighed the hammers, and found that the sweet pairs shared whole number ratios. Whether the blacksmith story is true or not, what Pythagoras discovered is real. The pitch of a string depends on its length, and the intervals we find beautiful are simple ratios. Double the length, an octave, 2 to 1. 3 to 2, a perfect fifth. 4 to 3, a fourth. Music, it turned out, was numbers. And if music was numbers, and numbers ruled the cosmos, then the cosmos was music. Pythagoras proposed that the sun, the moon, and the planets each emit their own hum, tuned by the speed of their orbits, a celestial harmony, inaudible to us only because it never stops. Plato took the idea and built a universe out of it. In the Timaeus, the creator, the demiurge, constructs the world soul by dividing it according to the very ratios that make musical intervals. The cosmos is not merely like an instrument, it is one, tuned before it was wound. And the harmony of the spheres became one of the most stubborn ideas in history. Ptolemy, the greatest astronomer of antiquity, wrote an entire treatise assigning each planet its note. Cicero, for centuries after Plato, put the doctrine into the mouth of the dead. In the dream of Scipio, the great general hears a sound, so great and so sweet, the music of the spheres. The moon, nearest us, sounds the lowest note, the outermost heaven, the highest. And here is the most haunting part: the reason we cannot hear it, Cicero says, is not that it is quiet. It is that we have been hearing it since the moment we were born. You cannot hear the music of the spheres the way you cannot hear the air you breathe. The idea spread through the ancient world, carved into mosaics, painted onto ceilings, woven into the Roman imagination. Every schoolchild learned that the heavens sang. Aristotle was not moved. In On the Heavens, he dismantled the doctrine with a single question: if bodies the size of the planets moved through air making sound, we would hear it. We have been here since birth, and we hear nothing. The spheres, he argued, are not rubbing against anything. There is no air up there to carry a sound. The universe, for Aristotle, was silent. And yet the idea refused to die. It survived as metaphor. Boethius, writing at the dawn of the Dark Ages, divided music into three kinds: the music of instruments, the music of the human body, and the music of the world itself, which he insisted was real, even if unheard. Dante heard it. In the Paradiso, the spheres sing as they turn. Shakespeare knew it: there's not the smallest orb thou beholdst but in his motion like an angel sings. And then came Johannes Kepler, the man who discovered the laws of planetary motion, and who spent 20 years hunting for the literal music. In 1619 he published The Harmony of the World, mapping the speeds of the planets at their closest and farthest points onto musical intervals. He built a choir: Mars the tenor, Saturn and Jupiter the basses, Mercury the soprano, Venus and Earth the altos. And he found that the Earth, at its most eccentric, sings the interval Mi, Fa, Mi, and, he wrote, you may infer from this that misery and famine hold sway in this our home. But the planets did not sing as he hoped. The intervals were there, the song was not. And yet the very book that failed to find the music gave physics something else: the third law of planetary motion, the harmony Kepler had suspected all along, was hiding in the mathematics. Kepler concluded that the music was not audible, but that it was real, heard not by the ear, but by the soul. The idea should have died with Kepler. Instead, it kept returning, because the universe kept turning out to be more musical than we expected. In the 1960s, astronomers discovered that the sun itself rings like a bell, its interior resonating with sound waves that travel all the way through it. In 2015, the LIGO observatory heard something the Greeks could never have imagined: two black holes, colliding a billion light-years away, ringing spacetime itself. A chirp that rose in pitch as they spiraled together, recorded exactly as a sound. And in 2023, astronomers announced that they had finally heard the background hum, the faint, pervasive rumble of gravitational waves from supermassive black holes across the entire universe, detected by timing the pulses of dead stars with the precision of atomic clocks. We have even sent our own music into space, pressed onto a golden record, riding the Voyager probes toward the stars, as if to say, we heard it too. Pythagoras said that the universe is numbers, and numbers make music. He could not have been more wrong in the details. There are no crystal spheres, no celestial choir. And he could not have been more right in the shape of it. The cosmos does hum. The question the Greeks leave us with is not whether the music is real. It is why we, the only species that makes instruments, were the ones who heard it first.